The next issue I want to discuss is expansion. Now, when heated, all substances will expand, and albeit at different rates, they will expand. And when cooled, they will all contract. Now, the rate at which they do this is called the coefficient of expansion. Now, metals will generally have a larger coefficient of expansion than other materials. So what is the coefficient of expansion? Well, it's the expansion in unit length per degree rise in temperature. And this expansion can happen in three ways. You've got linear, superficial and cubical expansion. Linear is in one direction, superficial is in two directions, for example a sheet of metal, and cubical is expansion in three directions, for example a cylinder, the volume of a cylinder, three directions. Now remember that linear expansion is the coefficient of linear expansion, is in one direction. Superficial expansion is 2 times the coefficient of linear, and cubical expansion is 3 times the coefficient of linear expansion. So try and remember that. Superficial expansion is 2 times the linear, and cubical expansion is 3 times it. Let's do an example using this principle. Determine the final length of a beam that's heated in the fire to 415 degrees. Well, the ambient temperature of the beam, you start off with, is 15 degrees. The coefficient of linear expansion is 0.00015 degrees C. And the original length is 7.5 metres. Let's determine the expansion first. So what's the expansion? Well, the increase equals the coefficient of linear expansion times the temperature rise times the original length. Well, the increase equals then 0.00015 times the 415 minus the ambient, 400, times 7.5, which was the original length. This gives you an increase of 0.045 metres. So the final length, all you do is add them together. 7.5 plus 0.045, which is 7.545 metres. That is the final length of that beam. Let's do another example. Determine how much a metal bridge will expand on a freezing cold day when the sun comes out and heats it up to 30 degrees C. Now the temperature is minus 10 degrees to start with. The coefficient of linear expansion is 0.00032 degrees C. And the original length of the bridge is 50 metres. Well, first of all, you want to determine the expansion. Well, the expansion is the coefficient of linear, because you want to talk about linear expansion, times the temperature rise times the original length. Well, if you put these in, you get 0.00032 times 40, which is the temperature increase, times the original length, which is 50, and the increase is 0.064 metres. Yeah, 0.064 metres. And the final length is 50 plus 0.064 metres. It's 50.064 metres. That's how you do that. Now, can you see why bridges are required to have expansion joints to enable them to expand when heated on a hot day? They'll have expansion joints, rather than push them out on the fittings, they'll have expansion joints, which like a roller, which allows them to expand and contract on very hot days when there's big temperature differences.